Lesson 4.4, factoring quadratics with leading coefficients greater than 1. So we're going to always start by asking ourselves, is there anything I can factor out first? So we look at our 3x squared plus 5x minus 12, and the answer to that is no. Then we might ask, is it a special products polynomial? And again, the answer is no. So when the leading coefficient is greater than 1, we can multiply the first and the last terms together. So that's what we'll start off with. So we'll say 3 times negative 12 is negative 36. So we'll bring down our first term, 3x squared. We bring down our last term, the minus 12. Now we ask ourselves, what is going to multiply to negative 36 yet add to the middle term 5? So you could say, start listing factors of 36. 6 times 6, 12 times 3, 9 times 4, and then we can see there's a relationship between the 9 and the 4 that would yield the 5. So we'll use 9x and a minus 4x. So we can see the 9 and the negative 4 get us back to the positive 5. And if I multiply 9 and negative 4, we get the negative 36. Then we're going to factor by grouping. So we'll group our first two terms, our last two terms, and we have to put in our plus sign. Otherwise, it indicates that we're multiplying, and we're not. Now we look at our first binomial, and we're going to factor out a common monomial. So we're going to take out a 3x. So we're left with x plus 3. And then in our second binomial, we can take out a negative 4, and we're left with an x plus 3. We look at what we have left. So we have our lookalikes will be one set of parentheses, and our leftovers, not a mathematic term, is going to be 3x minus 4. So we just factored our 3x squared plus 5x minus 12. If I FOIL our answer here, we would get back to our original problem. I jotted down the basic steps for the example we just did, so you might pause the video and put those in your notes. And we're going to continue on to some special products cases. So we'll start off with the difference between squares. So because we have a subtraction sign difference and we have perfect squares, so we just have to find the square root. So we'll end up with 6k minus 3, 6k plus 3. And if I FOIL that, I should get back to my original problem. Perfect square trinomials. We ask ourselves, is there anything I can factor out? And the answer is no. And so I see that I have perfect square at the front and back end. So I'm going to try 5m minus 8 times 5m minus 8. Since they're the same, I can write it as 5m minus 8. And that quantity is squared. It had to be negative or a minus because the middle term here had a negative or a minus sign in front of it. If we were to FOIL at this step, we would get back to our original polynomial. So I've been saying always check to see if there's anything you can factor out first, and then check to see if it's special products. And we finally got to one where we can factor out a negative 4d, and we like to take out a negative so that our leading coefficient is positive. So when we take that out, we end up with 4d minus 3 in parentheses, and that's all we can do for that one. Next, we have a solve. So we need to collect our terms on one side. So I'm going to subtract 4r and add 5, subtract 4r and add 5 to both sides. Next, we're going to simplify this just a little bit by dividing every single term by 5, and then we'll go ahead and factor. So when we factored, we ended up with r minus 2 times r minus 2. Then we applied the zero product property. So we set one of the parentheses equal to 0. Since they're both the same, we just needed to do it once. So r equals 2. So now pause the video and try this last one, and then we'll check your answer. Okay, so the first thing we did was to factor out a 2, take out a common monomial. We were left with what's in blue, multiplied the 4 with the negative 5 to get the negative 20. We brought down the 4q squared and the minus 5 and asked ourselves what multiplies to negative 20 yet adds to the positive 19. So now we're going to group it. We'll put parentheses around the first two terms, parentheses around the second two terms, and a plus sign in the middle, and then we'll take out a common monomial out of the first binomial and one out of the second. So we'll take out a 4q, so we're left with q plus 5, and out of the second binomial I want to factor out a negative 1, so I'm also left with a q plus 5. We bring down the 2, our leftovers, 4q minus 1, and our lookalikes make up the second binomial. And if I multiplied all that together, I should get back to my original problem.